we're going to be going through the laws of exponents again, right? So these are all laws or rules or whatever you want to call them, but we need to remember them because as we are doing the calculations, we need to remember which ones to do when, right? Oh, excuse me. So we need to remember that if we have like bases being multiplied, we're going to keep our base and add our exponents. Now, I want you guys to be very, very careful here, okay? Because if I have 2 to the power of 3 times 3 to the power of 2, this does not give me 6 to the power of 4 just because the bases are not the same. That's not how maths works. Okay, we cannot do that, or 6 to the power of 5, in fact. Okay, we can't do that here. All right, 6 to the power of 5. It doesn't work that way. We need to make sure that the only two things we are multiplying together or adding the exponents of are bases that look exactly the same. All right, so we need to be very careful on what we're doing there. Likewise, if we have like bases being divided, we're going to keep the base and minus exponents. When we take a power of a power, wherever I see a bracket and an exponent, I'm going to keep my base and I'm going to multiply my exponents. M times n will give me mn. All right, now over here, if I have two different bases, I still have a bracket and an exponent. So each of the bases on the inside should get their own exponent. All right. Okay, this one is the same. Again, inside I have two different bases. Each of them should be multiplied with their own exponent. All right. Anything to the power of 0 is equal to 1. That's correct double distribution. And whenever we have a negative exponent, we cannot leave it with a negative exponent. So if it's sitting on its own, we're going to put it over 1. And then we're going to flip them. We're going to take that one to the top and bring this one to the bottom. Same as if I had 1 over a to the power of negative m. Because this thing at the bottom has a negative exponent, I still need to flip it. So I must take that one to the top to give it a positive exponent and bring the 1 to the bottom. So we can switch them around. All right, so we can do it going in both directions. It's not just the one direction. We can do it in both. So this will equal a to the power of positive m over 1. All right, my m looks a little skew here. Let's fix it a little. Okay, now I know that you guys have already done this, so I'm going to give you some time to practice. Can I give you guys some time to practice? I'm going to give you a couple sums, and you guys can try them and then put your favorite emoji in the chat when you're ready. I'm going to put that emoji. That's my emoji of the day because I'm so happy it's holidays, guys. Yo, hi. School is not for me no more. I'll see it again in April. I'm very tired. I want to go on holiday. All right, let's try these first 5 questions here. And when we've got the answer to those 5 questions, only once we've got the answer do we then put our favorite emoji in the chat. Okay, so try them. And when we're done, put your favorite emoji in the chat, please.
Ma? Any? Ma?
Tebogo, you're really fast. I think you're already done. We're just waiting on everyone else. Well done, my darling. We're going to give everyone else 1 more minute. All right, that's time. Let's have a look at some of these answers. All right. Okay, let's start with the first one over here. This one is quite nice and easy. I've got 2 squared times 2 to the power 4. Now, I'm going to note here that I have like bases. I've got a 2 there and a 2 there. When I have like bases being multiplied, I'm going to keep my base, and I'm going to add my exponents. 2 plus 4 will give us 2 to the power 6. And indeed, well done, Tebogo. 2 to the power 6 is actually 64. All right. Cool. All right. In this next one over here, again, I have like bases being divided. So I'm going to keep my base and I'm going to minus my exponent. So 4 minus 2 will give me 3 squared. And that is equal to 9. All right. 1 mark, 1 mark. Okay, now over here in question C, I want us to be very careful, guys. We need to note here that they're not actually multiplying. We are adding. We are adding. So I can't now say that my like bases are being multiplied, so I'm going to keep my base and add my exponents. I can't do that. Good, Deboha, that's it. I can't say that they're being multiplied. They're not. They're being added to each other. So we know that anything to the power of 0 is equal to 1. So 3 to the power of 0 is equal to 1 plus 3 to the power 4 is the same as 3 times 3 times 3 times 3, and that's going to give us 81. And therefore, our final answer, 1 plus 81 is 82. Right. In D, I can see here that we've got a bracket and an exponent. So I'm first going to keep my base. I'm not going to change my base. I'm going to keep it. And I'm going to multiply my 2 exponents. So that becomes 2 to the power 6, which is also 64. All right. In E, I'm going to note that my bases are not the same, but I still have a bracket and an exponent. So each of these numbers must get one of those. So I must go 2. By the way, when any number is sitting on its own, what is the exponent of any number sitting on its own, guys? If it doesn't have an exponent? Correct. Good. Sure, you're on fire. Excellent. If any number sits on its own, we automatically give it an exponent of 1. So both of these have 1. Now I'm going to get 2 times 1 and 2 times 1 there. So I'm going to keep my bases. So I'm going to write 2 to the power of 1 times 2 will give me 2 times 5 to the power of 2. 2 to the power of 2 is 4 times 5 to the power of 5 is 25. And that is equal to 100. That's the final answer we're looking for. All right, 1, 2, 3, 4, 5. Give me a number out of 5. How did we do? How much out of 5 did we get? Beautiful. Well done, Linomka. Well done, Teboho. Excellent, Wade. Okay, so this stuff is easy, right? I mean, we've done it before. There's nothing difficult here. I haven't really shown you guys something you haven't seen before. Tebogo, for which one? For the last one. Oh, okay. Let me guess what you did. You went 2 times 5 is equal to 10, and then you had 10 squared, and that gave you 100. Yes? Right. And you're not wrong, my darling. You're not at all. But remember what the question asked of us. Okay. The question said we must use the laws of exponents. So that's why I'm going in that direction, because the law of exponents shows me here that if I have two different bases inside the bracket, then I must distribute to each of them. Each of them must get their own bracket. I mean, their own exponent. Okay, so I'm using the instruction that I was given. Am I making sense? All right. Oh, I skipped one. Can we do this one quickly? Let's do that one quickly. Sorry, I should have showed you all 5 or all 6 of them. Okay, everybody's got 2 minutes to do this one over here. I feel like 2 minutes is stretching it. Maybe 1 minute. Yeah, 1 minute. Okay, we'll have a little bit of a look in just a bit, Ilham, and you'll explain to me. All right, but for now, let's quickly do F. All right. Okay, again, I see a bracket and an exponent. I know that the exponent of 7 is 1, so I'm going to distribute this 3 over here to each of those brackets. So what I should get here is 2 to the power of 6 times 7 to the power of 3. Right, now this is a huge number. Okay, and we know that with a number like this is what? If I write it out, I'm going to get 2 to the power of 6 is 64 times 7 cubed, which is 343. It's going to be really hard for us to find an actual number for this without using a calculator. So in questions like these, they wouldn't expect you to find the final answer. They would ask you to just leave the answer in exponential form. So there'd be no need for us to do the 64 times 343 part. We can just leave it over here. All right. All right. Here.
Laws. So if you guys want to take a screenshot of that, let's do it now. We can see everything. There we go. Okay. Right, I'm going to jump past those questions and we're going to have a look at these ones here, just because it's important for us to be able to practice. Oopsie. So we're going to have a look at these questions here. Hopefully I left myself some space, but we'll see how we go. All right, so we've got some examples that we want to simplify. So your instruction to all of these would be simplify the following. Now, grade 9s, please remember when you simplify, obviously you need to simplify as far as possible, but your answer should always only have positive exponents. And this is where it's really important that if you ever do get a negative exponent, you remember your negative exponent. Sorry. So always just bear in mind, sometimes in the instruction, it will say simplify, leaving all answers with positive exponents. So sometimes it does say that for you, but just in general, your answer should always have a positive exponent. Okay, so if we have a look at the first question, let's number this, question A. We have got 3 to the power 4 times 3 to the power 7 to the power 5 divided by 3 to the power 2 cubed times 3 to the power 9. Now, there's a lot going on there. So the first thing that we want to try and do is we want to try and do all of our multiplication, deal with all of our exponents before we even start with the division. Okay. Now, remember, if your bases are the same, you are able to apply your exponent laws. Now, the reason I'm making this statement is because if you have a look in your bracket, both of these values have a base of 3, which means that when we do go and start to simplify, I can just add these two exponents together because I'm multiplying. So in the bracket, 3 to the power 4 times 3 to the power 7, we can add those exponents together. Now, I'm not going to take up that much space. If we add those exponents together, we end up with 3 to the power 11 all to the power 5 divided by, now here, I'm sorry, my pen just hates me at the moment. Still going to hate me. Let's try a bit further over. Okay, seems to work here. Not really. We're going to roll with it. We can now distribute those two exponents. We would have 3 to the power 6. Okay, apparently this is going to work. Technology times 3 to the power 9. Now, normal multiplication, that means you can add those exponents. In the numerator, we would need to distribute. So we would have 3 to the power 55 divided by 3 to the power, and 6 plus 9 is 15. Right, so all we're doing is we are applying our exponent laws, our exponent rules that we know in order to start simplifying. Again, I can apply the multiplication ones because those bases were the same. Now, Sinyani told us earlier how we deal with division. If we've got the same bases and we are dividing, what we do is we subtract our exponents. So what we're going to have here is we're going to have 3 to the power 55 minus 15. And that will allow us to simplify to a single base. So 55 minus 15 gives us 40. If you don't believe me, obviously just use a calculator. That's absolutely fine. There's nothing wrong with that. So 55 minus 15 gives us an exponent of 40. And so what we have here is 3 to the power 40. Now, grade 9s, in this case, I would not go work that out as a number because it's going to be a massive number. And to write that down is just a mission. So what I would do here is I would just leave it as it is. I'd really like to be able to move my answer. Apparently, I'm not going to be allowed to do that. Again, technology is just biting me, which is fine. If you want to know what 3 to the power 40 is, my calculator doesn't even like it. I'm not even going to attempt to try this. This would have, it would be in like the trillions. Not even worth trying to write it down. Leave it as 3 to the power 40. You have simplified. Right, so now in question B, we've got some variables that we need to deal with. So if we have a look, we've got 15 times a cubed times a to the power 5 squared times b to the power 5 divided by 5 times a to the power 7 squared b to the power 6. So much going on. Go step by step. So the first thing I want to do is I want to deal with my brackets, deal with my exponents, simplify all of that as much as I can, and then I can deal with the division and simplifying the fraction. Right, so if we have a look here, sorry guys, my answers are a bit all over the place. Like I say, my pen and my screen don't really like each other at the moment. I'm doing the best I can. So in my numerator, I'm going to leave the 15 for now. We will deal with it, just not right now. I'm first going to deal with this bracket. They are the same bases. It's both a base of a. So I can add the exponents together, giving me a to the power 8. And I need to remember that's still being squared. Then I've got my b to the power 5. Again, I will deal with the division in a second. In the denominator, I still have the 5. I'll deal with it later. And now I need to distribute this 2. So I've got a to the power 14, b to the power 6. So I'm starting to simplify. In my numerator, I still need to distribute that exponent. Now, guys, be very careful. This exponent of 2 applies only to this bracket. That 15 in front of the bracket is not inside the bracket. It's outside the bracket. It has got no relationship, nothing with that exponent of 2. The 2 only applies to that bracket containing a to the power 8. So 15 remains, but now we've got a to the power 16, b to the power 5, over 5, a to the power 14, b to the power 6. All right, and now this is where we can deal with the fraction. This is now where we can simplify. Now, I don't know how many of you were with Watobi last year when I was teaching grade 8s, but one way that I know, or that I used to simplify, is SNV. Do you know how many of your teachers do this? Signs, numbers, okay, numbers, variables. So that's just how it's going to be apparently tonight. If you work in those 3 steps, just deal with your signs first, then your numbers, then your variables, it's so much easier to multiply and divide. So if we deal with the signs first, positive 15, positive 5. A positive divided by a positive is a positive. My answer is going to be positive. So that's the signs done. Now I move on to the numbers. Now the numbers are these coefficients in front. 15 divided by 5 gives me 3. And now I can move on to my variables. Now grade 9s, please remember that when it comes to your variables, you have to work with the same base. So the A's are going to work together, or you're going to work with the A's together, and then you're going to work separately with your B's. You cannot mix and match your bases. It must be the same base. Now grade 9s, there's a few ways that you can do this. If you would like to apply your exponent law, by all means go for it. Personally, I don't enjoy doing that. So I do it slightly differently. If we do apply the exponent law, this is division. So this is telling me to subtract my exponents. So I would have a to the power 16 minus 14, which gives me a to the power 2. And then I would have b to the power 5 minus 6, which gives me b to the power negative 1. Now remember I said we want to leave all of our answers with a positive exponent. So the rule for negative exponents is that you take the base and its negative exponent and you change its position within the fraction. So this is technically a fraction over 1. And all we're going to do is going to take that b and that negative 1 and we're going to move it down. That's all you do. You don't move anything else. The 3 is fine. The a is fine. It is just the b that we have an issue with. And so our final simplified answer here is going to be 3a squared in my numerator divided by b in my denominator. That's it. Everything now has a positive, a little English. Everything now has a positive exponent. I'm happy with my answer. So personally, I don't like to subtract the exponents because if I can avoid ever having to see a negative exponent, I will. The way I personally do it is I know that a to the power 16 means that I've got 16 a's in my numerator and 14 a's in my denominator. All 14 of those a's will divide away with 14 of the a's in the numerator, leaving me with 2. All 5 b's in my numerator will divide away with 5 b's in my denominator, leaving me with 1. And so I can immediately see that I've got a remainder of b in my denominator. You don't have to do that, right? There's no reason for you to do it that way. If you want to do it that way, fine. If you're happy to use your exponent laws, also absolutely fine. You pick the way that works for you, and that's what you work with. Okay, so let's take a screenshot of this. And then I think we'll have a little brain break before we carry on with this equation situation next. Remember, grade 9s, if you've got questions, please just ask. You can raise your hand. You can put it in the chat. I know this is revision, but doesn't mean you don't have questions. Okay, let's stop scribbling on the screen, please. That's not going to happen. I will just remove you. Okay, you all should have your screenshots. Brain break time. So I quite enjoy teaching cats brain breaks. So there are some would you rathers. So first one, would you rather carry a flip phone or only use a desktop computer? Now, flip phone is not like that fancy Samsung thing that's out at the moment. Flip phone like that. Okay, flip phone. Desktop is the one with like the big box next to it. Would you rather only charge your phone once a week or not have a camera on your phone? Would you rather have to listen to only Justin Bieber or only Ariana Grande for the rest of your life? Love to hear what we have to say. If anyone wants to unmute to give their opinions, let's hear your voice. Flip phone, interesting. And then desktop. We have some Ariana Grande fans or just some Justin Bieber haters. You know which one. No camera on your phone. I feel like my brain has just had a brain. So you'd want to charge it once a week and then have no camera. Okay, my brain's worked. I think I would agree, Caleb. Like you can do more on desktop. So I think I would go desktop. I think there's more that can be done. And I suppose you could put like WhatsApp and stuff on the desktop, especially in this day and age. Flip phone, no camera, Ariana Grande. Justin Bieber, okay. Clearly, we need to charge our phones quite a lot. Symptom delay, please stop with annotations. I will just get rid of you. Okay, I've got another one for you. Would you, oh, English. Okay, let's try this. Would you rather be able to breathe underwater or fly? So breathe underwater or fly, which one? Interesting. I think I would go with breathe underwater. I'm scared of heights, so I don't think I want to fly. And I think the ocean's quite cool. I'd like to be able to swim and see fun things. Okay, I've got another one for you. Would you rather eat pizza for the rest of your life or ice cream for the rest of your life? Interesting. Okay. Pizza, 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 pizza. No one taking up ice cream. Okay, here's one. Would you rather have to sing everything that you say? So when you speak, you do it in song form, or would you rather not be able to speak? Interesting. I'm going to be honest, I think I would rather not be able to speak. I could write down what I want to say. I don't know if I want to sing every day. But clearly we've got some singers in the group, which is awesome. Nice, guys. I'm interested that so many of you would say not have a camera. Stereotype of your generation. Yeah, we should know better. Hey, and we had a lot of Ariana Grandes. Interesting. Very nice. Okay, let's get back to some exponents. Let's see what we have going on here. Woo. All right, so before we get to the equation situation, there are 5 questions here that I want you guys to give a try of. So it's just applying the laws. It's very similar to the examples that we just did before our brain break. So there's 5 questions here. I'm going to give you, let's call it 7 minutes to give these a try. Please do actually try them. Remember, this is you revising the stuff. We actually need to do it. Do it on your piece of paper. You're also more than welcome to put your answers in the chat. Ask questions if you're feeling a bit confused, but let's try this. Remember, you have to fully simplify and leave your answers with positive exponents. But yes, let's do it. Right, so 7 minutes, and then we'll go through the answers. Grade 9, can I just ask, if you do put answers on the chat, will you just number them? So 1, 2, 3, 4, A, B, that's also fine. I know what you mean. Just so that I know which answer is which. Great, guys. Keep those answers coming. Doing really nicely. Remember, guys, if you have any questions, just ask. Very nice. When you're done, will you just give me a thumbs up? Your 7 minutes is nearly up, but obviously I don't want to rush you. So just give me a thumbs up if you're done. When you're done. Thank you. Cool, thank you. I see your hand. Yeah, I'll give you 1 more minute and then we'll have a look. Okay, grade 9, let's have a look. If you're not done, don't stress. You can just grab a screenshot, but mark as we go along. Hopefully the first one wasn't too bad. We are dividing, so we subtract those exponents, x to the power 3. Okay, so not too tricky. Number 2, also not too tricky. We just have a coefficient there. So remember, SNV, positive divided by a positive is a positive. 21 divided by 7 is 3. Y to the power 7 divided by y to the power 4, y cubed. Right, from 3, things do start getting a bit trickier because there's a little more that we have to deal with. So if we look at question 3, the numerator is fine. I've got no issues with what's going on in my numerator, but I can simplify what's going on in my denominator. Now that's just multiplication. So we add the exponents. Remember, b has an exponent of 1, a has an exponent of 1 in the bracket. So a squared b times ab cubed. Add your exponents of a, you end up with a cubed. Add your exponents of b, you end up with b to the power 4. Okay, it wasn't a power raised to a power needing to distribute. It was just normal multiplication. Now we can go and simplify. A to the power 6 divided by a cubed is a cubed. B to the power 9 divided by b to the power 4, b to the power 5. Alrighty. Question 4, a little bit going on here. We've got some coefficients. Those coefficients, however, can't be simplified. So 4 over 5 is going to remain in the numerator and denominator because I can't actually do anything with them. In terms of my x's, I've got x cubed divided by x squared, which leaves me with x in my numerator. Y to the power 16 divided by y to the power 5 gives me y to the power 11 in my numerator. So your answer here, 4x y to the power 11 all over 5. Remember that 5 was in the denominator, so it needs to stay in the denominator. Then for question 5, we do need to do a bit of simplification before we rush into things. Again, the 24x squared y cubed is just a normal multiplication with a 2x to the power 8. So we just multiply normally. 24 times 2 is 48. X squared times x to the power 8 is x to the power 10. And then we've just got that y cubed there. I don't know why I've written it so far away. Shame. That's a bit mean. All over 6xy squared. And now we can go and simplify that. All right, so silly thing. Start with your coefficients. Remember, SNV, there's no negatives here, so we don't have to stress. 48 divided by 6 is 8. So technically, that's an 8 over, so apparently that's a fraction line, over 1. But if 1 ends up being the only thing in our denominator, we can just ignore it. I'm going to leave it like that for now, just in case. X to the power 10, stop with the annotating. X to the power 10 divided by x is x to the power 9. Y cubed divided by y is just y. So actually, I didn't need that 1 in the denominator. It's just 8x to the power 9 y. Okay, so guys, really importantly is that we're always applying our exponent laws when we need to. What you'll see is as the questions get a bit more complex, there'll be different ways that you can do the same thing, but as long as you apply your law, you will be fine. So let's take a screenshot of these 5. If anyone has any questions about where they maybe went wrong or what they didn't understand, now's the time to ask. Otherwise, we'll have a look at those equations now. All right. Okay. So if we have a look at these first sort of basic equations. Now remember, with exponential equations, there's something really important that you need to remember. And that is we'll go here, is we want to make our bases the same. Now you can actually use your calculator for this. I'm not sure if Teacher Cat showed you this, but I'll show you how to do this now in this first example. So if I just grab a calculator quickly, sorry. Especially if you're not sure what the factors of a number are. No, right, so for this first example, we've got 2 to the power x. Okay, hopefully you can all see the screen now with the calculator. Just give me a quick thumbs up, someone, that you can see the calculator. Anyone? Can we see the calculator? Thank you, thank you. Alrighty, cool. So the first example, we've got 2 to the power x equals 32. So like I say, the key with exponential equations is you want those bases the same. We have a base of 2 and we have a base of 32. I need to make them the same. Now, because 2 is already a prime number, I can't actually do anything with it, but 32 I can. Now, if you're not sure what 32 is written as 2 to the power something, use your calculator. Right, so you would type in the number you want to make a prime base, so 32. Oh, hang on, I'm in the wrong mode. Let me just get in the right mode. Right, so we would type in 32 and then we'd say equals. 32 is equal to 32, great. Then what you do is you say shift and then fact, which is on top of this button over here with like the comma looking things. And we say shift fact. And what your calculator does is automatically gives you what this is, what this number is as a prime base. All right, so this is now 2 to the power 5, and we can see then that those bases are the same. You can do this with any number. So shift fact on your calculator, super, super useful. So in order to make these bases the same, I'm going to be able to say, I'm going to be able to say 2 to the power x. Okay, it's not working there, so let's try here. 2 to the power x is equal to 2 to the power 5. Once your bases are the same, what you then want to do is you want to equate or make your exponents equal. So what we now do, bases are the same. So that's one part of my equation equal. I now just need to get my exponents the same. And so I now say x is equal to 5. Now in this case, I don't actually need to do anything more because that's already solved. But now I know that x is equal to 5, as some of you had already said there on the chat. So the key is making your bases the same. So if we apply that same thing with question B, we have got 3 to the power x equals 81. So again, use your calculator if you're not too sure what it is. We did actually have this example earlier where we had 3 to the power 4, which is 81. So we make our bases the same. 3 to the power x is equal to 3 to the power 4. And then we equate our exponents. X is equal to 4. Right, so exponential equations really not too tricky as long as you can do, or as long as you can make your bases the same. So now we've got in question C, 5 to the power x is equal to 3,125. That's quite a big number, but I've now shown you how to do it on your calculator. I want you guys to try that quickly for me and tell me what x is. What is the value of x in question C? Let me see one answer. I'm assuming that we're giving it a try. Right, so if you use that shift factor on your calculator, you get that 3,125 can be written as 5 to the power of 5. My bases are the same, so now I make my exponents equal to each other. X is equal to 5. Remember, grade 9s, you can double check yourself. If you substituted back into your original question, you must get that the left is equal to the right. If we substitute this x back into the original and say 5 to the power 5, it is equal to 3,125. So you got the right answer. That's how you double check yourself. All right, so I want you guys to try for me these last 4 questions here. So D, E, F, and G. You've got 9 minutes. I'm going to give you 7. Well, we have 9 minutes left of the lesson. I'm going to give you 7 to give these ones a try, and then we'll go through them in the last 2 minutes. Remember, ask your questions as you go along. If you're not 100% sure, just ask, and then we'll check, like I say, in 7 minutes time. And remember, like Roha's done there on the chat, if you're going to put answers in the chat, just remember to number them so I know what's what. Great, grade 9 is doing really nicely. Simtantile, thank you for letting me know that you're done. Guys, again, if you're done, just give me a thumbs up so that I know. A couple of you who are on G's, that's awesome. Still got a few more minutes. Okay, guys, let's have a look. All right, so question D, we've got 2 to the power x equals 8 rather. 8 can be written as 2 to the power 3, which means that x is equal to 3 for question D. For question E, we've got 5 to the power x equals 625. 625 can be written as 5 to the power 4, so x is equal to 4. Question F, we've got 3 to the power x is equal to 9, which can be written as 3 squared. And so x is equal to 2. So those first three shouldn't have been too problematic. Maybe struggled a little bit with question G, but let's see. So now we've got 5 to the power x plus 1. So there's a bit more going on in my exponent is equal to 25. Now, guys, you know that 25 can be written as 5 squared. And so once my bases are the same, I equate my exponent. So x plus 1 equals 2. Now, remember, you're solving for x. You're trying to find a value for x. I'm just going to carry on up here, which means you need to use your inverse operations. Now, inverse operations tells me that I need to subtract 1 on both sides of my equal sign or both sides of my equation. And that will give me x is equal to 2 minus 1, which means that x is equal to 1. Obviously, you can go straight to the answer. You don't have to do this 2 minus 1 step. I'm just showing you that inverse operation. But whenever you've got multiple terms in your exponent, it doesn't change what you do. You get your bases the same, and then you equate your exponents. You might then have to solve an equation, but the method that you use doesn't change. Alrighty. So I saw a lot of really nice answers coming through, so very well done. As you